Hello, today I'd like to introduce you our LTTsmart NVH set. So this is here the 2-channel high sampling DAQ device with IEPE sensor supply, analog input, DC input, and it can be also switched to as a charge input. Here at the DIN connector we have the possibility to connect strain gauge sensors in full bridge, half bridge and quarter-inch bridge. So the completion resistors are already built in the system. So means you can choose it later if necessary by the software. So this is a very powerful system with 24-bit delta sigma ADC and with additional anti-aliasing filters. So in this session I like to show you the performance of the system. So I have here as first IEPE sensor, in this case it is a microphone. Then I have here a function generator. Here I have an adapter. So after the calibration I will remove the microphone capsule and use this adapter so that I can supply the signal from function generator via this IEPE preamplifier, the microphone preamplifier, to the DAQ device. So with this chain we can measure the performance of the IEPE microphone preamplifier with the IEPE chain to the ADC. So and then we will see the performance, how it is reflecting to our measurements. So now as first I start the software. So it's now for you in English. Now the system getting initialized, and now we have here several possible options. So if we like to make FRF modal analysis or impact hammer measurements, so then we would choose this one. Or for this presentation I will use here the vibration analysis and odor and acoustics analysis module, but we have here also dual plane balancing or balancing of 4 planes or rotational analysis. So it's depending on the system how many high-speed RPM inputs we do have. So here we see the sample ratings, the sample rates. So the maximum sample rate of this system is 4 MHz. So I will be here at 2 MHz. So in this case I have now here the microphone. So means the IEPE current is now set to 4 milliampere. This is recommendable, especially if you have long coaxial cables. So 4 milliampere is a good setting here. Range input is here 10 volt and MP30 microphone. This is here the unit. Okay, so if we like to make something like high-speed RPM measurements, so then we can choose this button here, but for this presentation we don't need it. So here we can set at 2 kHz or 2 MHz sampling rate. We have an analog bandwidth up to 100 kHz. So we calculate here with factor 2.5. nearly to the Shannon sampling theorem. So I will just exit here. Now I will make a different arrangement. So like this. So now I will go to the calibration menu. I will move this a little bit like this. So I will check now I will put the microphone here into the calibrator. It delivers now 94 dB, so means 1 Pascal. Let's see what happened. So now we see here the signal, it's there. This microphone capsule has a sensitivity of 56 millivolt per Pascal, and I just start right now the calibration. So the calibration is done. I will recalibrate again, just to make sure. So now, in the next step, I just remove, here's the calibrator, and remove, here's a microphone capsule. So the microphone capsule get here this special housing, so that it is good protected. So now I use here this adapter. So now it's here to this function generator connected. So I will adjust here now 1 kHz. And here again 50 millivolt per Pascal, or let's say 56. So again 50 millivolt RMS. Okay. So now I activate the signal. Now we see here a small difference, but it's no problem. I just recalibrate here this. So now it's done. So in the next step, I will show you the performance of the system. So we will be here in this calibration menu. I just change here the display settings. So here and then I will measure, let's say, to 1 megahertz. So now I just start the measurement, and here at the left side we see now our peak. So this is very strong compressed from the 1 kHz. Now I key in here 100 kHz. So now we can see here, our peak is at 100 kHz. So the signal go from here to the microphone preamplifier and then here to the LTTsmart device. I just remove this, boom, no signal. Connect, zack. Okay, so now we can see here the performance of this IEPE sensor chain is very good. At 100 kHz we have zero damping. So it's an excellent result. So now I will go to 200 kHz, 300, 500 kHz. So now we see here almost zero damping, even a little bit amplification of 0.1 dB. So now I'm at 800 kHz. And now we can see here from 94 dB it goes down to 93.8. And this is now the point where the anti-aliasing filter from the LTTsmart is active. So now if I go to higher frequency, so then we see here strong damping. So now again back. So I can go now okay. So in this presentation we can see that this measurement chain is extremely excellent with 24-bit resolution. We have here a fantastic system which can grow also with your challenges in the future. So it has, as I mentioned, now we are in the mode of IEPE sensor supply, which is AC coupled, single-ended, but we have here many other possible hardware input settings. So DC single-ended with at the BNC. It can be also at the DIN connector. So here with the IEPE. So AC, this is what we got now. And here you see the settings for full bridge, half bridge, quarter bridge. And very important, it's also here that the bridge completion resistors are already built in the device. So here we have the single-ended charge input BNC and so on. So it is a very good system. Even now it's also possible with this device to go to 4 kHz sampling rate. And of course this is simultaneous sampling, so means each channel have own ADC with 24-bit resolution, so it's a superior performance. So now I can go again here to calibration menu. So now I'm at 1 megahertz. Now let's okay, this is now here the limit of this microphone preamplifier, but it is anyway very good for a measurement microphone preamplifier that it goes almost up to 1 megahertz analog bandwidth. Of course, it is possible to do with the system many high sophisticated measurements and scientific measurements. So if we go here and we change the measurement, then we can make impact hammer measurements here with the impulse hammer. But this is now for this presentation of the LTTsmart, I think too long time. So thank you very much for today, and I wish you a pleasant time. Goodbye.